All right, so this is going to be the last problem in this series of videos on exercise 4, and all the problems that we're solving are unsolved ones taken from the book Higher Engineering Mathematics by Dr. B.S. Grewal. Problem number 8, and we need to solve this. We need to find the 4 roots of this algebraic equation using the Descartes method. What is the first thing that we need to do, sir? What we need to do is to work out whether it is in the format or not. Sir, this is not in the Descartes format. Why? Because we can clearly see that there is this x cube term which exists. So we need to get rid of this term. How do we do that? Sir, we can actually diminish the roots by h. How do you find h? This is the formula for h. And by the way, all of these things have been explained in detail in my previous videos on transformation, as well as in the examples involving the Descartes technique. Okay, to watch them. Sir, the value of n is the degree of the algebraic equation, that is 4. A1 happens to be -10 and A0 is going to be 1, coefficient of x power 4. So let me plug in all of these values. This gives us a fraction 5 by 2. That means when you diminish the roots by 5 by 2, automatically this term, x cube term, is going to disappear. But we've got a fraction, and whenever you see a fraction, whenever you see the value of h as a fraction, I mean, you may get into trouble if you straight away apply the diminishing of roots concept. That means you can use the synthetic division technique, and then you can note down all the remainders one by one, arrange them in proper sequence, and that will get you the equation. We are going to approach this using 2 stages. In first stage, please note, in first stage, since we've got the value of h as 5 over 2, in first stage we are going to multiply the roots by 2. Okay, and when that happens, you will have an equation in y. Now consider the equation in y. You are going to then diminish the roots, subtract the roots by 5. Then you are going to have an equation in z, and there you will observe that there is absolutely no x cube term. Let me implement these things and I'll summarize everything for you, don't worry. Okay, everything will be super smooth. Here we go. Let us start with the stage number 1. Let's multiply all the roots, all the 4 roots, okay, of the given equation by 2. And to do that, what we have, we can do this. Y is equal to 2x. Okay, so you can say, sir, x is equal to y over 2. So at all of these locations, you can plug in the value of x as y over 2, and but again, there is going to be a lot of calculation. So if you want to get rid of this calculation, there is a short trick which all of you can do. Multiply all of these terms with increasing powers of 2, like 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Okay, all of these terms starting from here, 2 power 0, 2 power 1, 2 power 2, and so on. The power of x is decreasing continuously, and here the power of x happens to be 0, and the powers of 2 are increasing continuously. So please notice this pattern. Done, sir. Do the simplification. Okay, this is going to be very simple. 10 into 2 is 20, 44 into 4 is going to be 176. So yeah, do the math. So stage 1 is complete, sir. We have ensured that all the roots have been multiplied by 2. Now if you want, you can get the value of h. H is nothing but minus 1 over n. N is nothing but the degree, that is 4, multiplied by a0, not a0 but a1, that is -20, sir, and divided by the coefficient of y power 4 is 1. So that's 1. What is the value of h? Okay, now sir, we have got an integer. Initially we were getting a fraction. Okay, now we've got rid of that denominator too. Wonderful. Let's go ahead with stage number 2. We are now going to diminish the roots by 5. How do we do that? Take a look at this process. 5, that is our equation, current equation in y. Okay, 1 minus 20, 1 minus 20, plus 176, plus 176, minus 832, minus 832, plus 1536, plus 1536. Wonderful. Copy paste. 5 1 is 5, minus 15, into 5, minus 75, plus 176 is 101, into 5, 505, minus 832. This is what you get. And finally 5 into 327. Do the math. Plus 1536 minus 1635. That's what you get. Okay, a special aqua color has been assigned because these remainders at every juncture is going to be very important for us. Please note it down. Copy paste again. 5 into 1 is 5. Now this boils down to minus 10 into 5 minus 50. This is 51 into 5 will give you 25, 255. Okay, minus 327 plus 255 minus 72. You need to stop here. I mean, this is how you are going to get the results. Okay, one more data in aqua color and these two datas. Anyway, keep watching. Copy paste again. 5 into 1 is 5, minus 10 plus 5 is minus 5, into 5 is minus 25, this is 26, and yeah, we are almost done. Copy paste again. 5 into 1 is 5, this is becomes 0. Now if you watch, now we are going to have an equation in z power 4, z cube, z square, z, and you can say that there is a positive sign over here, isn't it? Now if you watch, z power 4 plus 26z square. Done. What else? Sir, minus 72z minus 99. Minus 72z minus 99. And this is our equation. And now you can clearly see, is there any x cube term that you can observe? No, sir. There is no x cube term. And hence, you can now very confidently and straight away apply the Descartes method, which says that this equation can be equated to the product of two quadratics like this. Okay, equation in z, product of two quadratics. And before that, let me summarize what we've done. We started with this given equation, which was given. Okay, given equation, right? So we ensured that we have an equation in y where the roots are doubled 2 times, right? Then we diminish the roots to have an equation in z where y minus 5. We have diminished the roots by an amount of 5, right? This is our final equation, and we can clearly see that there is no x cube term, and hence we can go ahead with it and apply the Descartes technique. Take a look at the RHS only, do the math, multiply, open the bracket, expand, and when you arrange all of these terms, I think I have spoken about them, these things in detail. Okay, this is what you get. Arrange all of them properly, sequence. Let me have the equation in z, and let us now try to make comparisons. Green with greens, that means coefficient of z square. Q dash minus p square plus q is equal to 26. Take p square to the RHS. This is going to become positive, and that's your equation number 1. Again, take a look. Blue, coefficients of z. Okay, so pq dash minus pq is equal to negative 72. So take p as common, and now take p to the other side. That's your equation number 2. Done. Very easy. As far as third equation is concerned, it is about the constants. Therefore, qq dash is equal to negative 99. That's the result. Now let me have all the equations in one single frame. Done. What's next? Sir, we are going to square equation 1 minus square equation 2. That's what we are going to do. Q dash plus q whole square minus q dash minus q whole square. You can see these things. Secondly, p square plus 26 square minus 72 by p and its square. So this is going to be very simple. You know this. This is going to be 4qq dash. Secondly, p power 4, and 26 square is 576 or 676. 676. Okay. Then 2 into 26 into p square will be 52 p square. Similarly, 72 and its square will be 5184 and divided by p square. Done. Very easy. Now, sir, we know the value of qq dash. How much is that value? Sir, it is minus 99. So you need to plug in minus 99 over here. Into 4 will give you the value as minus 396. Now, you can take the LCM, which will work out as p square, and you can take that denominator over to the LHS. That is one way. The other way is to multiply both the sides by p square. The moment you do that, this is going to be p power 6. This is going to be p power 4. Let me simplify this and let me write it down. Minus 396 p square is equal to p power 6. 676 p square. 52 p power 4 and minus 51. These two are going to cancel each other out. Done. Let me bring this to the RHS. So 676 and 396, both of them will add up to 1072. Done. So we have arranged from higher to lower powers. Done, sir. Let's say p square is equal to t. Okay, this is p power 6 only. Okay, this is p power 4. This is p power 4 only. It is just the way we have written it. So p square, let us replace it with t. Now you can solve this cubic equation using a scientific calculator. I'm assuming that all my viewers are engineering students, first year or second year, and you're allowed to use that scientific calculator. Don't apply the Gardens technique. or even the what do you call inspection method, because that might take a bit too long. Your 5 minutes will be wasted. Okay, if you apply the Cardin's technique, maybe your 10 to 15 minutes will be wasted. So don't go for that. Use the calculator, punch in the values of A, B, and C and D as 152, 1072, and minus 5184. You'll automatically have the results as 4 and a pair of complex roots. 4 happens to be the perfect square, so select it. That means P square is equal to 4, P is equal to plus minus 2. Select the positive value and go ahead with it. So I've updated the list with the value of P. What's left? Sir, Q and Q dash both. How do we approach now? Plug in the value of P 2, P 2. Done, sir. Okay. Value of P happens to be 2. Let's say this is our new equation. 26 plus 4 will be 30. Equation 4. And minus 72 by 2 is minus 36. Wonderful. Add both of these equations. Plus Q and minus Q will cancel. Q dash plus Q will become 2Q dash. This is going to be equal to 30 minus 36. That is negative 6. Q dash will be equal to negative 3. Easy? Very easy, sir. Update. P, Q dash. Wonderful. Sir, we can put this value of Q dash over here. Q into minus 3 will be equal to minus 99. That means Q is equal to 33. Simple. So all the unknown values have been worked out. Let us now have some fun and let us now plug in the values of P, Q dash and Q. Okay, please match the color coding. Match the color coding. Wonderful. Okay, here we go. Let me separate these two. There are going to be 2 roots for Z from both of these quadratics. Okay, 2 from here, 2 from here. That makes it 4. Let me make some space, and we are going to be using the very popular Sridharacharya formula. Okay, now watch. Sir, A is equal to 1, the coefficient of Z square. B is equal to 2, the coefficient of Z, and C is equal to 33. In the same fashion over here, A is equal to 1, B is equal to negative 2, and C is equal to negative 3. So punch in all of those values into this formula. That's what you get. 2 square is 4, 4 minus 4 into 33. So whatever it is, try to solve it. Inside the root, you will have a term of minus 128. Secondly, if you try to solve this, 2, 4, 4, 12, 12 plus 4 is 16. This is going to be 16. Very simple. Okay, take a look at this. This is going to be a complex pair, let me tell you honestly. Because inside the root, we've got a negative sign. So 128. What? Minus 128. So we can also write minus 128 as minus 1 times of 64 times of 2. Okay, 64 can be taken outside. 8 is 64. And this is going to be root 2. And this is going to be under root of, change the strategy, under root of minus 1 and under root of 2. So under root of minus 1 basically is iota. So 8 iota root 2. Okay, follow this first of all. Plus minus 8 iota root 2. Here it is. Easy. And then do the division. This is going to become minus 1 and 8 by 2 is 4. Easy. Take a look at this now. 16. Root 16 is 4. 2 plus minus 4 by 2. So basically 1 plus minus 2. 1 plus 2 is 3 and 1 minus 2 is minus 1. So these are the 4 roots. Let me write them down. Okay. No need to get happy. This is not the final result. This is just the value of Z that you've got. And from Z, you need to get the value of Y. And from Y, you need to get the value of X. How to do that? Let me rewrite these equations. Let's say X is equal to Y over 2 and Y is equal to Z plus 5, isn't it? So we've got all the values of Z, haven't we? So if you've got the value of Z, you can get the value of Y. If you've got the value of Y, you can get the value of X. And that is what we'll do. So I've written down all the values of Z. You just need to add 5 to all of them. Plus 5, plus 5. When you do that, you get the corresponding values of Y. Let's do it. Here we go. And now you need to divide all of these roots by 2. When you do that, you have the corresponding values in X or for X. This is the final solution, which I'm sure you all must have understood. If you've got any doubts or queries, do write them down in the comment section. I'll be very, very happy to answer them. Okay. And if you find this content to be helpful, do like the video and share it with all your friends and classmates so that they can also benefit. This is Manas Patnaik signing off. Take care. Have a nice day. Keep watching. Thank you.